GCO13, use coordinates to prove geometry stuff. And I think that's kind of the best way to describe this because it's not like there's any one little thing that makes it. Anyway, we're going to just keep on moving on. So, so the stuff that you're going to have to prove are things about geometry. So things with geometry, one of the popular things, the first things that a lot of people learn about geometry are about triangles. And so with triangles, we would have things like, whoa, okay, we would have a right triangle. This is a right triangle. How can you tell that this is a right triangle?
90-degree angle.
Yeah, that would be 90-degree angle. And if you were to graph it, how could you tell it was a right triangle?
Pythagorean theorem.
Yep, it fits the side lengths all fit. And then because Pythagorean theorem is really long to write out, I'm just going to write a squared plus b squared equals c squared. So that's one way to do it. Another way to tell it, so that's with the sides. Another way to tell is that it is a right angle. And one way that's really easy to tell is like one of them's on an up and like vertical line and one of them's a horizontal line. But if it was at a funky angle, then this is what you need to know. The slopes of perpendicular lines are opposite reciprocals. So meaning like if we had one of the slopes was 2, the perpendicular would be perpendicular to one that is negative 1/2, because the opposite of 2 is negative 2, and then the reciprocal of 2 is 1/2. Or let me give another example. If we had a slope of 3/4, the perpendicular would be negative 4/3. So if the slopes follow that, then we know it's a right angle. And if it's a triangle, then it would clearly be a right triangle. Do you want me to give another example of a slope and you can do the opposite reciprocal, or do you feel like you raise 1 to 5 on understanding opposite reciprocal?
3,000.
5, you've got it. Okay, good. All right. So you have a right triangle. Another kind of triangle that you might have is you might have a isosceles. Can you see that okay? Isosceles. What makes an isosceles triangle an isosceles triangle? So at least 2 sides are congruent. Can I just do congruent like that?
Yeah.
So you would probably, in order to find those lengths, you would need to use a squared plus b squared equals c squared again. And if 2 of them are the same length, boom, it's an isosceles triangle.
Wait, so technically an equilateral triangle is our isosceles triangle?
Yep, yep. So that's the other kind that he just said. We have equilateral. I'm going to put it underneath. Is all sides are congruent. And again, you'll have to use the Pythagorean theorem. But then there's something that's sneaky, and you were taught this before, I think, but I don't remember when. But there is something called the triangle inequality theorem, THM for theorem. And it says that, so you have 3 sides, right? So I'm going to call, with a triangle, I'm going to call one side A, one side B, and one side C. In order to make a triangle, 2 of the sides, when you add them up, they have to be greater than the 3rd side. If it was not greater than the third side, it would not make a triangle. Do you want to see an example of this?
Here we go.
So, here we have one side, right? And then I have another potential side and another side right here. Oh, actually, let me go like this. Okay, and another side right here. And notice that these two lengths do not add up to the length of the pink side. So there's no way that I could make a triangle from it. So it's just impossible to make a triangle because they don't meet up. Does this make sense? Okay. And then, yeah, that's basically it.
How does an equilateral triangle?
Huh?
How does an equilateral?
How does an equilateral triangle work? Then all the sides are just the same.
Yeah.
Yeah, but that wouldn't work with the
But two of the sides,
Oh.
when you add them up, would be definitely greater than the other side, right? Because if they were all 3, then 3 plus 3 is definitely greater than 3.
Yeah, I guess.
Oh, really?
By 3, it's 3 greater. Yep.
Wow. Whoa.
Yep.
It's amazing.
Okay. So those are triangle things. Next thing we have are quadrilateral things. How many sides do quadrilaterals have?
4.
4. Good job. So they definitely have 4 sides. And so let's go through specific things about quadrilaterals. And I should be pausing the video.
That's okay.
Whatever.
Bye,
It's a
video.
nice buffer for them to get
Okay.
snacks.
Nice buffer for snacks. Okay, quadrilaterals. So what's like the easiest quadrilateral you can think of?
Square.
A square. So there are a couple things that make a square a square. One of the things that makes a square is that there are, if you want me to draw a picture I can, but I think you've got it. There are 4 right angles. In other words, you want the slopes have to be opposite reciprocals. Op-recip. Opposite reciprocals. So to do that, you can do opposite reciprocals. So that would be, but even if you had just opposite reciprocals, that could also be, what also has 4 right angles?
Triangle.
A triangle. Okay.
Rectangle.
So these could also be a rectangle, which is okay. So then what makes a square a square?
All the sides are equal.
Yeah, all sides, and then I'm going to use congruent because it's fancy. Which again, to find out if sides are congruent, what theorem do you have to use? Pythagoras' purchased theorem. Remember?
Yes, you're great, Dan.
Sneaky sucker. Okay, so all sides are equal. There are other things, but just for what you need to do, like this is what makes a square a square. If you prove that all 4 angles, like all of the angles are right angles, then you can say that it's a rectangle. How can you prove that a parallelogram is a parallelogram?
They both have 2 parallel sides.
Yeah, so let's see, parallelogram. Which I like to abbreviate as parallel lines, ogram. Okay. Parallelogram. So then all opposite sides are parallel. How can you tell if things are parallel with the slope?
They don't intersect. We know.
Parallel means same slope. So perpendicular means that the slopes are opposite reciprocals, but parallel means same slope. So you could check and just make sure that the opposite sides have the exact same slope, and boom, that thing is a parallelogram. Let's do another one. Let's do a rhombus. How can you tell a rhombus is a rhombus?
If it got ran, if it was a square that got ran over by
All
a
sides are
place.
equal, but it's slanted.
And actually, technically, a square is a kind of a rhombus. It's the main thing with this is that all sides are congruent.
Oh, and opposite angles.
All the opposite angles are congruent, but the only thing that you would need to prove with this is just that you could prove, because proving angles on a graph is really hard. The only thing that you can do on a graph really easy is the slopes.
Isn't a rhombus technically a parallelogram?
A rhombus is a kind of a parallelogram, and a square is also a kind of a parallelogram, and so is a rectangle. Okay, let me see. Oh, and then I didn't put on triangles. I forgot one on triangles. Oh my goodness. What kind of a half-rate teacher am I? Okay, I forgot with triangles that we also have a scalene triangle. What do we know about a scalene triangle?
All
All
sides are
sides are
different.
80.
All sides are different. Okay, another thing that you need to know for this is some just fancy geometry terms. What does adjacent mean?
Opposite?
Next to.
It means next to. Adjacent, so if you have adjacent sides, they're the sides that are right next to each other. And then, yeah, those are the main things that you need to know. So that is GCO 13, using coordinates to prove geometry stuff.